Bienvenidos, Ushamdi, and welcome CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4 course, or the Connecting Networks V6 course from Cisco Networking Academy. And this morning's Packet Tracer video tutorial and solution set is going to be on Packet Tracer Activity 4.1.3.5, where we're going to begin our conversation about access control lists. And specifically, our focus in this Packet Tracer tutorial is going to be on standard IPv4 ACLs. Now, one of the things to remember about the standard ACL is that it can only match on source traffic, right? So in other words, we can only identify traffic based off the source address. So here's our activity, and this is the topology we're going to be working with. We're going to be implementing some ACLs here. We've got some usernames and passwords for privilege exec mode. And so let's scroll up just a little bit here. We'll try to keep that in view. And let's get started here. So configure a standard IPv4 ACL to restrict access to the pink LAN, right? So the pink LAN is going to be this one down here in the lower right-hand corner. So the color starting from the top, we've got top left is yellow, bottom left is green, top right is blue, and bottom right is going to be this pink LAN. So let's take a look here. Outline what you wish to accomplish. So access list 10 should have 4 ACEs, right? Access control entries, and that's what we refer to, the entries that we put inside of an access control list. Now, before we craft this up, let's remember that a standard ACL is nothing more than a packet filter at layer 3 and only at layer 3. A standard ACL cannot look at anything above layer 3. So in other words, we can only look at IP addresses, and we can only look at source IP addresses in these ACLs. Now, I'm stressing packet filter here because this is one of the things that confuses a lot of learners new to ACLs, is they see often, and even the book talks about it, that you can implement sort of a rudimentary firewall using ACLs. Now, this is true that you can use ACLs to protect your network. However, standard ACLs are stateless. And what that means is that they maintain no state information. They are literally evaluating packet by packet the layer 3 header information where you have your source IP. That is what's being evaluated. The switch or the router on which we place the standard ACL is not keeping track of the flow of the conversation between the end nodes, right? So in other words, when we look at the topology that we're working with here, and this is an important point, if PCG down here in the pink LAN is communicating over here with PCA, and let's say that for the sake of argument, the PCA is a web server, and PCG wants to communicate with PCA to get web pages and whatever other web content PCA might be serving up. If we've got ACLs, standard ACLs here, and standard ACLs here, right? If that's how we're doing it, and we're allowing HTTP outbound and we're allowing HTTP inbound, right? With a standard ACL, you can only allow based off the source IP, okay? So we can't allow HTTP inbound. We can't go above layer 3. We can only do it, and let's say that the address down here is 10.1.1.10. If we only wanted to allow that host to come through, right, this is how we would apply it, is with the IP address. But the point is that even with extended ACLs, there's no state information being tracked here. And there's one exception, and then that's the established keyword that we talked about on Tuesday night, when we'll look at that when we get into the extended ACL packet tracer activities. But again, the key takeaway is that ACLs are stateless. They are not maintaining flow and conversation information about the end-to-end conversation, right? The source port, the destination port, how many bytes have been tried. They're not keeping any of that state information, right? So it is literally the most rudimentary, basic form of packet filtering. And with a standard ACL, that is all we are doing, is filtering packet by packet, inspecting the source IP address in the IP header. All right, so let's dive in here. I wanted to make sure that we covered that to be clear, because it becomes confusing when we tie in, oh, you can do a firewall with ACLs, right? And that tends to cause a little confusion, because ACLs are not stateful. They are stateless. They do not track any state information. All right, so access list 10 should have 4 ACL entries to do the following. Start with the following comment, right? So we're going to put a remark in there. Permit PCC, who is over here, to reach the pink LAN. And so remember, when we're talking about standard ACLs, where do we want to place the standard ACL? So permit only the first half of hosts on the yellow LAN so that they can reach the pink LAN. Permit all of the hosts on the blue LAN to reach the pink LAN. Access list 10 should be configured on the correct router and applied to the correct interface in the right direction. And this becomes important because with a standard ACL, we can only filter based on the source. So here's the requirement. PCC wants to come over and talk to the pink LAN, right? So we should permit PCC to reach the pink LAN, permit only the first half of hosts on the yellow LAN, right? So we're going to say that these guys, right, will block off this. They want to come to the pink LAN. Permit all of the hosts on the blue LAN to reach the pink LAN. So then everyone from the blue LAN is going to come down to the pink LAN. Now, when we're looking at this, with a standard ACL, the ACL, if possible, should be placed as close to the destination as possible. And here's why. If I were to create, and remember, we're creating a single ACL, so it should be obvious that if I put the ACL here, right, what's that going to do? Yeah, that only impacts the blue LAN, right? These guys here, there's no ACL as they travel over here. It's only on that interface. What if I put the interface, or I'm sorry, the ACL on that interface? Yeah, the problem with putting it here is, remember, I can only say source address and allow that inbound. So I'd be cutting half of the yellow LAN off from the blue LAN, right? And so that would be a problem because that's not one of the requirements. So the requirement is that we've got PCC, and the same is true. If I applied the ACL here, right, the closer we get to the source with a standard ACL, the more likely we are to block traffic that we do not wish to block. So, because if I put the ACL here, we have the same problem as when I put it right there, is that PCC is going to be able to get through to the pink LAN, right? But D can't get to blue, and these guys, right, or I'm sorry, half of these guys will get through, but the other half won't be able to get to blue. So that's a problem because we're not supposed to be cutting off communications between other colors here. And the same is true if I put it here. Well, it only affects PCC, but then what about PCD? He can't get out at all, right? Because we're blocking, or I should say filtering, based on the source. So same thing here. When we look at this, it makes sense to put it right there in the outbound direction, because that is the interface where all of the hosts that are going to be trying to get to the pink land are going to converge. They don't all converge here. They don't all converge here. It's on this pink land facing interface where they converge. And so we would put the standard ACL that can only block on layer 3 source information as close to the destination as possible. And hopefully that's clear as to why we would not do it there, we would not do it here, we would not do it here, you wouldn't do it here, and you wouldn't do it here, right? Okay, so let's clear the screen. So we know the router on which we want to place the ACL. We're going to do it on router 2. So let's bring router 2 up. And let's stretch this out here and get the CLI churning away. And I've got to pay close attention to the name that we're working with. All right, so the username is going to be admin01. Password is Cisco PA55. And we'll go from user exec to privilege exec with secret PA55. All right, so we're now in privilege exec mode. So I'm going to say show IP interface brief. So as you can see, we've got 3 gig interfaces. If I scroll up just a little further here, on router 2, right, it doesn't tell us which LAN we're dealing with, but we can figure it out because the PCs, so PCH, I'll lower this down a little bit more, PCH happens to be in the 172.16.2, right? So here it is. So it's gig 01. And if you want to make sure we confirm that, let's get into global config, interface gigabit Ethernet 01, and I'm going to say shut. And we should see this link go red. So all I'm doing here is confirming, yeah, I've definitely got the right link. And we confirmed with IP address, but it's always good from a physical perspective to confirm things as well. So I say no shut, we bring it back up, and we'll go ahead and we'll let packet tracer converge here, because while it's converging, this is what we want to do. And this is a good best practice, is before you begin throwing ACLs all over your environment, confirm that connectivity actually works before the ACL is applied so that you've got something to compare it against. So let's pull up PCA, and I'm biding some time here, waiting for, let's give it a second here. And all right, that link is green. So we'll go to the desktop, we'll go to the command line, and I'm going to say, I'm going to ping PCG, which is 172.16.2.100. So can I ping from PCA down to PCG? And we should ARP once or twice here possibly, and then we should have reachability, because we haven't applied any ACLs unless, and I may have missed it, unless other ACLs are applied. So no connectivity, whoops, no connectivity there. Let me check router 1 real briefly here, and let's see, do we have any routing information in here? And we're going to need the username info again, and let's get that into site here. Admin01, Cisco PA55, and secret PA, whoops, secret PA55. All right, what about show IP route? All right, so it looks like there is no routing information here to get to the 172. So that may be a problem. Let's say do show IP route. All right, so we are not advertising. We've got a default static that goes out gig02. What about over here? We've got a default static that also goes out gig02, which is that link right there. So let's see, can I ping it from here? 172.16, and maybe I typoed the IP address, 172.16.2 dot, and I think I did. I can ping 100, can I ping 200? I think I ran myself down a rabbit hole here. 16.2.200. Okay, we do have connectivity. What IP did I type in? 172.16.2.100. I certainly did. And now it wants to work. Okay, so now it's working. So a little sketchy there, but that's okay. And then let's check PCC, because we're going to be creating the ACL, manipulating that PCD should not be able to access, but PCC should. So 172.16.2.100. And it should go to its default gateway, which is going to be router 1, and router 1 knows how to get there, as we see. So we've got connectivity there, and let's go to 200, and we've got connectivity there. Now, last one we'll check here. We'll check PCD, because PCD is going to get cut off here. So let's make sure that first we understand and know 16.2.100 that PCD actually can reach the destination. So he can get to PCG, and then PCH is 200. All right, so we've got connectivity. Now here we are on router 2, and let's bring this back up into the fold. So let's get our ACL rocking and rolling here. So access list 10, and again, it's a numbered, because we can do named ACLs, and to do a named ACL, it starts with IP access list. But since it's just a numbered access list, we simply go with access list. Now the range that we can use is 1 to 99, and then it's 1300 to 1999. And for this one here, as you can see, Packet Tracer, they're not going to give us the extended range for the standard ACL. So simply access list 10, and let's make sure we get this in order here. So access list 10, access list 10 standard, or access list 10, and permit, and actually want the remark first. So we'll do remark and ACL underscore 2 underscore pink underscore LAN. So first we'll put this in, access list 10 remark, ACL 2 pink LAN, and then permit PCC to reach the pink LAN. So now we're going to say access list 10 permit. Now remember, source IP PCC is 192.168. and I'm looking back up here to make sure we get this right, .2.50. Now there's a couple things that we could do here. I could approach this with a wildcard mask, just like we do when we enable OSPF on a single interface IP address, right? Where we put the quad zeros. But you can also put down, and let me say no to that, you can also put down the word host. So you can see here, we can do the wildcard bit. So I could do this, and that would mean just that IP address. Or I can say permit host, and my guess is this is what they're looking for. And so host 192.168.2.50. And so let's see if we get any movement on our completion percentage. Nothing yet, but we're going to go with that. So that's for PCC, and then permit only the first half of hosts in the yellow LAN so that they can reach the pink LAN. So we see the yellow LAN over here, and that's PCs A and B, and it's 192.168.1, and it's a /24. Now it's asking us to permit only the first half. So what would that look like? So we would say access list 10, permit, and it's going to be a range. So how do you divide up a /24? Exactly. You can cut it in half, and you would end up with 2 /25s, right? So if we wanted to divide it up, instead of using a /24 subnet, we would use a /25 subnet. So let's say 192 and I'm looking back up there, 192.168.1.0, because remember, it says the first half, not the second half, the first half. So what would the wildcard mask be for a /25? Well, we know that the subnet mask for a /25 is 255.255.255.128. Because if we have a /24, the last octet is all zeros, right, on a /24. We've got 8 bits here. And so with the /24, we've got 254 usable IPs, right? We've got the broadcast address and the network address that we can't use, but we've got 254 usable IPs. Well, if we want to cut this in half, we can borrow the first host bit and make that a network bit. And what is the value of that bit position? Exactly. The leftmost bit, the high order leftmost bit, is a value of 128, because then it's 64, and then it's 32, and then 16, and so forth and so on, just cutting in half, 8, 4, 2, and then 1, right? So we end up with this range of addresses here that we can use. We get 254 usable with a /24. We borrow the first bit, it cuts it in half, and this is my new dotted decimal notation for the subnet mask. So remember, if I'm just subtracting the subnet mask, right, to get the inverse, which gives me the wildcard mask, I simply take away the dotted decimal /25, right? Dotted decimal version of a /25, which is 255, 255, 255, 120, and I subtract that from the all 255s. And again, once you do this a few times, you learn quickly that, yeah, that's 0.0.0.127, right? So that would be my wildcard mask, and that also limits me to the first half. And let's get that typed in here. So we're going to say 0.0.0.127. Again, I can't put the destination, right? That's it. It's source address only with that standard ACL. So we'll drop that in there. Now it says permit all of the hosts on the blue LAN, and that's E and F. So when we take a look at E and F here, we can see, and they're making it nice and easy for us here. It's a /24, so this will be very straightforward. 172.16.1. So I'm going to say access list 10 permit 172.16.1.0 and then 0.0.0.255. And we're very, very comfortable at this point with a /24 wildcard mask. We've seen this many, many times, right? And so we add that in. And that is the third statement. It should be configured on the correct router. So we're already on the correct router, right? So let's get into the correct interface. Gigabit Ethernet 01. Again, if I were to, and I won't shut it down, but that is the right address because that is facing the LAN. If I say do show IP interface brief, we can see gig 01 faces the 172.16.2. This is our default gateway address for the hosts on the pink LAN. And when we look up here, at H and G, we see it's 172.16.2. So let's get into interface, gig 01. I think we're already there. And how do we apply, how do we apply the command? And Andrew had a question about this. Do I say IP access group or do I say access class? Right, now you'll notice there is no access class command here, right? And is there any IP access class? Let's scroll back up. No, right? So it's IP access group, and then we put in our standard ACL. And again, if it's a named ACL, we would put the name, but it's just simply a standard numbered ACL. So we're going to put the number, and that's 10. Now, we need to determine what direction, right? And remember, when we're talking directionality, it's from the perspective of the device and the interface on which we're placing the ACL. So here is the interface, okay? So it's not, and again, and this is critical because this is a common point of confusion, is that, and this is wrong, I'm going to show you the wrong reasoning and logic here, is that you're saying, oh, well, I would do it in the inbound direction because it's coming inbound to the LAN. And that's the wrong logic. Remember, it's not from the perspective of the LAN that's over here. It's from the perspective of the router and specifically the interface on the router. So from that perspective, the perspective of this interface is the traffic from all of these LANs over here, the green, the blue, and the yellow. Is it going to come inbound to the interface? This would be the inbound direction to that interface. Or is it coming out of that interface? Yeah, it should be obvious when you draw it out like this that we're talking about an outbound ACL, right? Because inbound is traffic that's coming into the interface. It's before it reaches the router and the router makes a routing decision on it. Think of it like that. Outbound is that the router has already made the decision as to what the outgoing interface is going to be, and then it's sending it to that interface, and it would be evaluated by the ACL, right? So this ACL would clearly be on this interface and clearly in the outbound direction. So let's go ahead and make that application here and say access or IP access group 10 out. And we should see a little bump in points, and we do, right? So very, very key there. Now let's go ahead. It says create and apply and test access list 10. So after configuring and applying it, remember a ping from host A in the pink, in this, I think a ping from host A to the pink LAN should be successful because A is up over here. So now we've applied the ACL. Let's validate because this was working before and it should be working now, right? Because if I say ipconfig, and I'm hoping that this command is on here, it is. You can see that that's my IP address, right? So I'm definitely in the first half of the LAN. So can I ping 200? I can. What about 100? So super, working great. So let's pull PCB up now. And we'll go to the desktop and we'll say ipconfig because I want to make sure. Yeah, so 150, that's in the second half of that /24 that we carved up into two 25s. So let's go ahead and ping 172.16. What am I looking at? 2.100. And this should not work, right? And as you can see here, it doesn't. So where else should it work? And take a look at what we get. We're receiving a destination host unreachable. So we're receiving a reply, and this is different from what we saw the first time when the pings were failing, right? Is that we didn't see this, we just got the periods, okay? So let's go to PCC. PCC should work, and there we go to 200, everything works fine. Let's go to 100. And now the moment of truth here, PCD is another one that we tested, and it worked. Is it working now? No, now we're getting a destination host unreachable. Let's check to go 100. Destination host unreachable. So PCA worked and B did not. PCC worked, but D did not. And the blue LAN should still be successful. And actually, we didn't come over here and test, but that's okay. So we'll say 172.16.2.100. And this guy works like a champ, and we'll check 200 just to be sure. So we've got connectivity there. Let's check PCF briefly. And we'll just check one of them here on PCF, 172.16.2.100, and it works, right? So what message is sent back to the PCs when a ping is denied due to the ACL? And we saw that here. It's reply from, and we get this IP address here. So this is the guy, the layer 3 device, right, that is sending this message, right? Reply coming back from 192.168.252.2, do show IP interface brief. And it's that gig02 interface right here is where the message is coming from, right? So it's this router, router 2, replying back to hosts that are attempting to ping through router 2 because the ACL, it's going to say destination host unreachable. So which IP addresses on the yellow LAN are permitted to ping hosts on the pink LAN? So this goes back to our subnetting. So remember, we took that /24, 192.168.1.0/24. We took that range, and so the usables in this range is a /24. That's my network ID, and so then from .1 to .254, with .255 being my bcast, right, my broadcast address. So that was the entire range. However, things have changed because I've subnetted over here. We subnetted this network and carved it in half. And that's how we've constructed our standard ACL. So when we look at this as a /24, we see we get that whole range of addresses, .1 to .254. But when we carve it in half, what takes place? Exactly. We end up borrowing a single network bit out of that last 8 host bits, and that value is 128. And this is that little trick I showed you about block size. So if I say that, okay, we're going to do 2 /25s, because now it becomes a /25 when I borrow, right? And remember, we've got the zeros over here for the other network bits. When I borrow that first host bit and make this a /25, we start at 192.168.1.0, right? So .0 is the first network ID. The block size takes me to the next network ID, which would be .128. I simply add the block size to the previous or the preceding network ID. So I end up with 128. And again, if I added another 128 here, right, and we came over here, it would take me to 256, and that's out of bounds. Whoops, it's a terrible 6. So that's out of bounds, so we know that that's where we end at 255, because we can't go to 256. So what are my usable IPs in this range? It would be .129 all the way to .254. And that's my /25, right? And that's the network ID. There's my broadcast address, and here are my usables. Over here, it would be .1 up to what? The broadcast address is our easiest one to figure out, 127, because it is right before the next network ID. And then that leaves me at 126. So here's my usables for the first subnet, or the first half of that /24, and here are the usables for the second half of that /24. So that answers that question right there. So, oh, and I should say which ones are permitted. It's the first half from .1 to .126. All right, so let's configure a standard ACL. We're on to the, whoops, I want to take those guys out of the view. So we're on to the remainder of the activity here. Configure a standard IPv4 ACL to restrict access to the blue LAN. So here's the blue LAN. So again, when we're dealing with standard ACLs, it's all about being able to filter in a stateless fashion on the source IP address, right? It's all about the source. And when we apply a standard ACL, we know that we want to apply it as close as we can to the destination. And so as soon as you see this, restrict access to the blue LAN, you should immediately be coming over to the blue LAN and seeing where is the closest place to this destination in the requirement that I can apply this ACL. And it's very similar to the one that we just did, is that interface right there is a very attractive candidate, right? Because that is as close as we can get. But let's check it out. Let's see what happens here and see if it plays out that that's going to be the location to do it. We're going to do access list 20. And where did the mouse go? There it is. We're going to do access list 20. We should have 3 aces on here. Again, this is going to be on router 2. And so let's dive in. And actually, let me read through here real quick. PCA can reach the blue LAN, deny the yellow LAN altogether, and allow all other networks to reach the blue LAN. Access list 20 should be configured on the correct router and applied. So yeah, so we're in the right spot. So let's bail out of here. And let's say access list, and we need a remark, I'm assuming. Or did it want a remark? Yes. Okay. So, and our remark is going to be ACL_2_blue_LAN. So PCA is allowed to reach the blue LAN. So again, pretty straightforward, right? So access list 20, because we're going to add this access control entry to this access control list. So access list 20 permit the host, who is going to be PCA, and of course I'm past PCA's IP here, 192.168.1.100, and that's it, right? So we're going to permit PCA to reach the blue LAN. We're going to deny the yellow LAN from reaching the blue LAN. So here's where we're going to come in and say, oops, access list. Some typing issues today. Access list 20, deny the yellow LAN. Now, here's the thing to remember about the yellow LAN is that we are looking at A and B, and it's a /24, right? So here in the yellow LAN, it sees it as a /24. When we did the ACL, we carved it up to pretend that we were going to be looking at half and half, right? The lower half and then the upper half, those two /25s, those ranges that we worked out, .1 to .126 of the usables, and then .129 to .254 of our usables. But in reality, if I come over here to router 1, and we go into, oh boy, we're going to put this information in here. Let's get that information back up there. If we come over here to router 1 and I say admin 01, and it's going to be Cisco PA55, and then we go into privilege exec with secret PA55. If I say show run, we can see that how is that LAN configured? That's the green LAN. And nice that they've got comments in here, making it easy. So yeah, you can see that it's true. It's a true /24, right? It's not 225s. We did the 225s because the requirement was to only allow the first half of the /24 to come through, right? So on router 2, we're denying the whole /24. So let's go ahead and do that. And I should have probably taken a closer look. 192.168.1. All right. So we're going to say deny 192.168.1.0.0.0.255. And so this also addresses Andrew's question, right? Is that we wanted to do it in this order, and when would you have a mix and match of permits and denies? Here's one place where that may be something that you've done or that you decide to do, is that you make the entry for the host first, and then we decide, oh yeah, let's just block the entire yellow LAN, and then let's come back down here, deny the yellow LAN, allow all other networks to reach the blue LAN. So this statement right here is very important, because if I apply this access list right now, what's going to happen? There's a couple points here. Remember, we have an implicit deny all at the end. You never see it in here, right? But it's there. It's there to protect you from forgetting to put it in there, right? It's protecting you from making a mistake, right? But again, it can cause some mistakes, because if I stop right now, what's going to happen to the green LAN? Is the green LAN going to be able to get in over to the blue LAN? And the answer is no, because we've explicitly permitted this host 100 out of the yellow. Oh, okay, I see what they're saying. Okay, sorry, access list. I'll make sure I'm doing this right here. PCA. Yeah, so we permitted the single host coming out of the yellow LAN, PCA. Then it said deny the yellow LAN from reaching the blue LAN. So then we deny everybody else, but we have to have it in this order, right? Because if I didn't do that first, and then this was first, this denies everything before it even gets to that statement. Because remember, it's evaluating the statements line by line, top to bottom. So that's why we have to have PCA in there, but then we're blocking everybody else. And then it says allow all other networks, which means the purple network is going to want to get in there and the green network is going to want to get in there. But this doesn't say just purple and green. This says all other networks, because maybe we're going to add another little square over here that's going to be, what's another color? Green, red, purple, who knows? And again, so we want to make sure we take that into account, that these other LANs may be coming over, trying to get through. So this is where we have to make sure that we're aware of the fact that there is that implicit deny all at the end, And if we want to allow everybody else through, we would say, I keep putting IP, access list 20 permit any, right? And that's it. Access list 20 permit any. And that's going to permit everybody else to come through router 2. So now let's go ahead and get onto the right interface here, the blue LAN, and let me review one time here, E and F, so 172.16.1. So let's do a do show run. There's the pink LAN, and where is my blue LAN? All right, so the blue LAN is gig 00. So let's get into interface gigabit Ethernet 00, whoops, 00, and let's say IP access group, and then what was the number of the ACL? And again, if there was a name, we would put the name here. So I'd say 20, and now again, are we filtering in the inbound, right? And don't think of it like this. Oh, it's inbound to the LAN. It's not about the LAN. It's about the interface on the router, because that is where the statement's being applied, right? It's on the interface. And so from the perspective of the interface, to get to the blue LAN, do we go out the interface to get to the blue LAN, or do we come into the interface to get to the blue LAN? What direction do we go on that interface to get to the blue LAN? Exactly, we go outbound. So from the perspective of this interface on this router, if we want to filter traffic trying to get to the blue LAN, we would apply it on that interface in the outbound direction. So let's knock that out, because that is as close to the destination as to where everyone's trying to go as possible. So let me pull the router 2 back up. We say IP access group 20 outbound, and we should get a bump in points on that, and we do. All right, so create, apply, and test access list 20. So again, we didn't test before, and that's okay. So let's go to PCA, and let's see, can I get to ping 172.16.1.100, and let me confirm that E and F, I'm sorry, 1.10 and 1.20. So let's do a control C there, take away a 0. Now PCA, should PCA be able to get to those hosts? Absolutely, because that was a specific requirement, that PCA on the yellow LAN, but it was also a specific requirement that nobody else from from the yellow LAN should be able to get there. So let's go 172.16.1.10, and there it is. And so that is the message that you would expect to see when an ACL is blocking you, right? And can I get to 20? I think that was the other IP that was for PCF. And there we go, destination timeout. All right, so PCA works, but nobody else on the yellow LAN does. Pings from host in the yellow LAN to the blue LAN should fail. They do. Pings from the host in the green and pink LANs should be successful. So we'll check from host D here, and let's say ping 172.16.1.10. And that works like a champ. And let's come over to the pink LAN here. We'll get PCG involved. And we'll say ping 172.16.1.20. All right, fantastic. And so we're getting replies back. Everything looks good. Now, how do you insert or remove an ACE, an access control entry, into a specific line of an ACL? And so we're going to be making a change here, and let me take a quick look at this. You need to make a change to access list 20. We need to insert an ACE, an access control entry to permit PCA to reach the blue LAN, and we've already got that in there. Insert the ACE prior to the other access list 20 permit and access and deny access control entries. So hold on a second. Insert an access control entry into the ACL 20 to permit PCA to reach the blue LAN. Well, we already have that entry. So how do we see? This is actually good, because now we're going to go ahead and take a look at, and I guess we'll leave it here for a second. So from here, how would I see if I said show access list? What kind of options do I have? Well, we can put the number. So show access list 10. So there's my ACL, right? And you can see that we're permitting host 192.168.2.50, which I could have sworn was PCA. I think that's PCA. Oh, you know what? I put 2.50. I put PC. Oh, I'm sorry, wrong ACL. Let's make sure we're looking at the right ACL here. So yeah, 1/100, that is PCA. And you can see it shows us the matches, right? How many packets have matched? And you can see that we have 4. If I was to go back real briefly here, if I go back to PCC and I ping again to 2.100, and then we pull router 2 up and I run this command again, and actually I did 2.100, I apologize. We want to do 1.100, so let's go 1.100. Or I'm sorry, that's my IP. Man, these colors have gotten me mixed up here. So PCE is 1.10. So let's Control C out of that, and we'll say 1.10, and that's a little better. And we should see an increase in matches, and we don't, but you should see an increase in matches, right? Because again, it's evaluating every packet one at a time. All right, so that's, oh, you know what? And I'm on the wrong PC. I'm on 250. So how about one last try with this? And I am completely turned around on this activity. Ping 172.16, and I'm pinging PCE.1.10. So there we go. So I'm on the right PC. I've pinged the right in-host, and now we will see that the matches go up, right? So you can see we have 8 matches now. So if I say show access list, the question becomes, how do I move entries around? Because, and I want to make sure we get this right, PCA can already reach the blue LAN, and that's what I'm having problem with here. Because remember, the number 1 requirement was only PCA should be able to reach the blue LAN. And this says insert an ACL entry so that PCA can reach the blue LAN, and insert the ACE prior to the other access list 20, and we've already done that. So I guess I'm at a loss as to why they're asking for us to do that. All right, so I'm going to come back to that. So what line did you enter the access control entry on? So we would want to enter it on the first line, but again, it's already there because that is PCA's IP, and that is what we are allowing. So this is interesting. So we're going to come back to this, because only PCA on the yellow LAN should be able to ping the blue LAN. All right, let's do this, and then we'll come back and see where we're at. So we're going to configure a named standard ACL. And actually, they're going to kind of give us a little assist here. So they're telling us that we're going to be doing this over on router 1. So let's bring router 1 back into the fold. We're going to have to enter our login information in here. Whoops. So we say admin 01. And Cisco PA55, and let's go from user exec to privilege exec, secret PA55. All right, let's get into global config. Now remember, for the named ACL, the only difference is we're not going to be using a number. We're going to say IP access list, and we say standard. And this is where, again, you can see it gives us a standard IP access list number, but we're doing a named ACL. Right, and so let's check the name is going to be admin _ VTY, kind of telling us where this is going to be placed. So what are we going to do? On router 1, create a standard ACL named admin VTY. Permit a single host, right, which is going to be PCC. So IP access list, whoops, I'm sorry. Now we're in the sub-configuration setup here. I got to transition from non-named to named. So now we're in this standard ACL named configuration section, and this is where I'm going to put my permits and my denies, right? So I'm going to permit, and let me check, do we want a remark in here? Are they asking for a remark? They are not. permit a single host. So this is where I'm going to say permit host, and then PCC's IP, let's get this right, is 2.50. So 192.168.2.50. And then that's it. We're going to apply the ACL to the VTY lines. Now, this is different than applying it to an interface. We're applying it to the virtual terminal lines. So I would say line VTY, we'll say 0 through 15. And here's where you see the access class command. And again, it's not IP access class, all right? And this is interesting. So, and this, Andrew had the question about this kind of related to his other questions. So when we look at this, you see that it says IP access class. Well, let's go to a real Cisco router here, just briefly. And where is Secure CRT on here? I got too much going on. And this is a Juniper router. So let's get on to a Cisco router. So here's a Cisco router. We're going to go to user exec to privilege exec. I'm going to say IP access list standard and admin underscore VTY, right? And then I'm going to say permit 192.168.2.50 because that is PCC. Then I'm going to go into line VTY 0 through 15, the first 15 VTY lines, and I'm going to say IP, and I'm going to do a question mark. Where is the access class command? It doesn't exist. And I think that that might be a bug with the packet tracer software that we're on what's supposed to be a router, right? Because again, and this is a router, this is a 2811, right? It's running 15 code. So let's come to a switch, and that's a Juniper switch, and that's a dead switch, and let's go on to the switch here. So if I came onto this switch here, and we said IP access list, and it's going to be, I'm sorry, standard admin underscore VTY, permit 192.168.2.50. And then I go into line VTY 0 through 15. I'm on a switch now, remember. And I say access class. There it is. And it wants the ACL. Is there an IP access class? There is not. So I'm convinced that this IP access class that Andrew ran into, that this is by mistake, that there should be no option. Yeah, look at that. Filter connections based on an IPv6 access list, right? So there should be no option here for IPv4. It doesn't exist. And it's interesting, it says filter connections based on an IPv6 access list. That is actually not how you do it. You wouldn't say IP access class, right? It would be what? Let's come over to a real router. What if I said IPv6 access class? Yeah. So this appears to be just a minor bug. IPv6 access class, right? There is no IP access class. Doesn't exist. It doesn't exist on the real Cisco iOS. So again, I think that the mistake here is that the IP access class that they put in here for standard, I shouldn't say for standard, for the application of an ACL onto the VTY lines, that this is a mistake, that you shouldn't see this. But I think Andrew was saying that if, because again, here, watch, if I say IP access class and I apply this, and what, we named it, I'm sorry, admin underscore VTY, and I say IP access class admin underscore VTY, and I hit enter, are we going to get any points for this? Oops. Left off the inbound direction, right, because it's coming, and let me make sure about that on router 1, permit C, so yeah, so inbound to the VTY lines, right? Do we get points for that? No, there's no points awarded for that, and there shouldn't be because this is an error, right? There is no IP access class on the real Cisco iOS. So we'll remove it. So the correct command is access class admin underscore VTY in. And it's that command that we should end up with, whoa, 100%, holy Toledo. Okay, That was worth 50% of the activity. Alrighty then. So let's validate though, right? So test access list admin VTY. So after configuring and applying the ACL, so an SSH to, or from C to 1 should be successful. So first let's try it from E. So can I go to, whoops. So we'll try it from E here. We'll say SSH minus L admin 01, and we're going to router 1, and it's the VTY line, so I'm just going to go to any interface, 192.168.1.1. And let's see what happens here. Right, connection timed out or remote host not responding. Let's try from C, and we'll use our default gateway here, SSH minus L admin 01, and we're going to go to 192.168.2.1. Take a look at that open password, right? So the password is Cisco PA55, and we're in. We're in router 1, right? So we've got all the points. We've done the validation. Again, the only thing that I'm questioning here is, how do you insert or remove an ACE into a specific line? So let's do that, right? Because we were dealing with access list 20, and it said, what line did you enter the ACE into? But again, it says you need to make a change, insert into access list 20, the permit PCA. Well, that's the first thing we did. So it shows up as first here as well, because that is PCA. So I'm not clear as to why they wanted to do that. But let's do this just to keep it interesting here. So let's go into global config, and I'm going to say access list 20, and you can see I can do, or actually, we could do this, IP access list 20, or I'm sorry, standard 20, and this gets me into the configuration section. So here's where I can go ahead and manipulate things, because if I do a question mark, you can see sequence number, right? So I'm going to put a bogus entry in here. Let's put it on line 99, and I'm going to say, permit, and we'll just do, 10.0.0.0.0.0.0.255, and leave it like that. So I'm permitting anything from the 10.0.0.0/24 network. So if I say do show access list, you can see that we're manipulating here. So where did it go? It went here, right? So let's say that I don't want it here. Or let's do this. Let's even do a trickier thing here. Let's do, and I'll change it. We'll change it to the 10.0.99 network, right? So now when I say do show access list, where did it put it? It put it here first, right? So that is how you would insert on a specific line if you wanted to juggle these lines around, right? If you wanted to, move something up or down, you could simply delete it. Or let's do this. Let's see what happens if I say, let's go back to that one we just did. Let me change it to 11. What happens when I do that? Does it create a new entry, or is it smart enough to take that entry and move it down to 11? Let's see. No, it actually doesn't even make the entry. So what we would have to do is say, no, 1, permit, and then do show access list, and now it's gone, right? And so if I wanted to ensure that no matter what, that entry for PCA was always the first thing evaluated, what would I do? I would say no 10 permit host 192.168.1.10, and this may blow up, or 1.100. This is probably going to blow up my packet tracer score, but that's okay, and yeah, it dropped it to 90. And we're going to say 1 permit host 192.168.1.100. And let's see, this packet tracer, is it going to recognize that? It's not. So maybe they were just asking theoretically, do show access lists. But that's how you can move entries around, right? If maybe something got inserted in before or after an entry and you wanted to make sure it got evaluated properly, you would simply go into IP access, like you do when you go to create a named access list, and then you would move entries around. All right, well, that is going to wrap up our tutorial on Packet Tracer Activity 4.1.3.5. All right, enjoy the weekend, stay warm, and I will see you all on Tuesday night.